Okay, so page 229, number 24. So this is probably one of the more difficult ones, maybe the most difficult out of the assignment, right? And as with any equation, there's more than one way to do things. However, looking at this, it does not appear that we can apply that strategy that we could apply to some of the other ones where we have a common denominator, and so we can combine some of our rational expressions. As you can see, in this rational expression, excuse me, the denominator is x minus 3. In this one, it's x plus 3. Not the same, right? So we cannot just add those together. And then in this expression, we have a third different denominator, x plus 3, x minus 3. If we wanted to, we could give all of these a common denominator and combine them, right? We could do that. I'm just not sure that's the most efficient method for this problem. Here's what I would propose doing. I would multiply both sides of this equation by the x plus 3, x minus 3. So it would happen like this. So I have that multiplying by this. Oh. And then I'm going to multiply this whole side by that as well. Now, on the left side, I'm going to have to do some distribution. I need to take this and multiply it by this rational expression and by this rational expression. Okay, so when I do that, when I multiply by the first rational expression, this x minus 3 and this x minus 3 will cancel out. And that leaves me with x plus 3 times x. So I'm going to write that down. I'll have the x times the x plus 3. Then when I distribute, I'll put my plus in there. Then when I distribute to my second rational expression, the x plus 3's are going to cancel out. And that'll leave me with 2x times x minus 3. So I'm going to write that down. Now over on the right side of the equation, I think it's pretty obvious that this whole thing will cancel with this whole thing and leave me with just 18. All right, now I'm going to distribute my x right here. And I multiply those together. I get x squared plus 3x. Bring down my addition sign. Then distribute the 2x here and here. So get 2x squared minus 6x. And of course, that equals 18. Now I start to combine like terms. I have 2x squared terms. X squared plus 2x squared gives me 3x squared. I have two x terms. Positive 3x and negative 6x combine to give me negative 3x, and that still equals 18. Now I like what's happening here because I see that I have a quadratic. I just need to put it in standard form by subtracting the 18 over to the left side. So I get 3x squared minus 3x minus 18 equals 0. Now I have a standard quadratic that I can solve. I can solve by factoring, I can solve by the quadratic formula, I can solve by graphing. You can decide which method works the best for you. I'm going to factor it. Second sign is negative right there, so I automatically have a plus and a minus. Factors of 3x squared are 3x and x. Now factors of 18, that will combine to give me a negative 3x when I combine the outside-inside of the FOIL method, right? But remember, this 3 right here is going to play a part in that. So we just recognized that 3 goes into that, goes into that, goes into that. So yeah, instead of factoring it as this quadratic looks now, it would be easier to factor out a 3. So let's go back and do that. X squared minus x minus 6. Now we can factor that quadratic. It's going to be a little bit easier because that leading coefficient is a 1. We still have our plus and our minus. Factors of x squared are x and x. Factors of 6, 3 times 2. We want a negative 1x as that middle term right there. So we could put the 3 with the negative and the 2 with the positive. And now we have to solve each of those. So we take each factor and set it equal to 0. 3 equals 0. Well, that never equals 0, so that's not going to give us anything. X plus 2 equals 0. Subtract 2 to the other side. X equals negative 2. And x minus 3 equals 0. Add 3 to the other side, and we get x equals 3. Now we do have to double check if any of those solutions make any of the denominators 0. So we need to go back up here to our original. And positive 3 is not going to work for us, right? Because that would make that denominator 0 right there. So we're going to have to throw that out. We're going to have to say x cannot equal positive 3. Negative 2 is going to work for us because it won't make any of the denominators 0. So there's our answer right there. All right, so this is number 23 from the same assignment. When I look at this, I see x squared minus 1 pops to me because I know that's a difference of 2 squares. So I could factor that, although I don't think I'm going to. I think I'm going to just cross multiply right off the bat. Because what I'm seeing is if I cross multiply right here, and then I cross multiply here, eventually I'm going to get a quadratic that I can probably put into standard form and then factor. If I factor x squared minus 1 into x plus 1 and x minus 1, I can't quite see what path I'm going to head down. And so I'm going to go down the path that I can see better, right? And that's kind of an important part of the problem solving because in algebra you have options for how to do things. You don't always know for sure which one's going to turn out the right way, but sometimes you just have to do what you know you're allowed to do, which is one thing that makes the algebra a little more difficult, right? Okay, so I'm going to cross multiply. So I have 4 times x squared minus 1, and I have 3, well, let's write it like this, 12 times 3 times x plus 1. Over here on the left, I'm going to distribute 4x squared minus 4 equals, over here I have 12 times 3, which is 36, and then times the x plus 1. All right, so I'm going to rewrite this, and over here I'm going to distribute my 36. Now I have the makings of a quadratic, so I'm going to choose to put that quadratic into standard form. I'm going to leave my 4x squared here. I'm going to subtract my 36x over here to the left side, and I'm going to subtract my 36 over to the left side and combine it with my minus 4, so that would give me negative 40, and that's all going to equal 0. So now I have a quadratic in standard form. I like that. I've worked with those a lot. I know I can solve it. I also recognize that 4 goes into each of those terms. So I can factor that 4 out. Now I'm going to factor the quadratic. Second sign is negative, so I have a plus and a minus. X squared factors into x and x. 10, factors of 10, well, of course, 5 and 2, but that's not going to get me a middle term of 9. So 10 and 1, and if I put the 10 here and the 1 here, my outside-inside terms, when I FOIL it to check, will give me that negative 9x. So now I can take each factor, set it equal to 0. Well, 4 never equals 0, so that's not going to do me any good. X plus 1 equals 0, so x equals negative 1. And x minus 10 equals 0. Add 10 to the other side. X equals positive 10. And of course, we have to check if any of those make a denominator 0, because then they would be excluded from the domain. So let's go back up here. We have negative 1 and 10. Well, negative 1's not going to work for us, because that'll make that 0, and it would make that 0. So we're going to have to throw out the negative 1, but the 10 will work. So we don't like this. This is our answer.